All right, we're doing 8.1 today, which is products and powers. So our objective is to multiply powers with like bases and to raise a power to a power. So let's look at some of these principles or properties. The principles used to simplify numerical expressions also apply to algebraic expressions. So the same principles we've been using. So the commutative and the associative properties of multiplication are used for multiplying algebraic expressions. So let's look at this product property here first. It looks pretty clear. Let me see if I could clear it up maybe a bit more. Okay, so this product property, we have x to the power of a times x to the power of b equals x to the power of a plus b. So when we have, notice they have the same base, okay, of x, we can multiply them and we add the exponents, a plus b. So it says to multiply powers with like bases, okay, we add the exponents. They always have to have like bases. Now we have the power property. So this is when we have x to the power of a that's also raised to the power of b. Okay, so x to the power of a to the power of b. And we're going to do x to the a times b property. So this is when it says to raise a power to a power, we multiply the exponents. So you got to remember those and keep them straight for when we're solving these, okay? That is on you to remember and memorize what you do when. Okay, so let's use those properties and simplify. For example, 1. It says apply the product property of exponents and the power property of exponents and the commutative and the associative properties as needed. So we have here, this is the product property. They have the same bases, so we're going to add the exponents. This is going to be x to the 5 plus 2 power, which is x to the 7th. B, we have x to the 5th power raised to the 2nd power. So this is the power property because x is to the 5th power and then we're raising all of that to the 2nd. So that's when we multiply our exponents. So x to the 5 times 2 power, which is x to the 10th. All right. Okay, C is when we're going to have to start combining some the properties in there, the commutative and the associative. Okay, so first we're going to do the exponent, right? We have y to the 3rd. All of that's raised to the 2nd. So this is when we multiply. We use that power property. So this is y to the 4th times y to the 6th, or the 3 times 2. Okay, but we're multiplying those properties. Now that we are multiplying these, that's the product property. We have the same base, so we add the exponent. So this is y to the 4 plus 6, or y to the 10th. Okay, in D, we have 3 times x, or 3x squared times 5x. Okay, so the bases, we talked about having to have the same bases so we can do anything. So we're going to have to pull the coefficients out of here, the 3 and the 5, away so we can deal with the bases. So this is going to be 3 times 5, and then we have times x squared times x. Okay, well 3 times 5 we know is 15. And then if we're looking here at x squared times x, okay, we have like bases. This is that product property. We have like bases, so we add the exponents. Notice we don't write an exponent for x, but we should know that it's 1. So this is going to be times x to the 2 plus 1 power. So this is going to be 15x to the 3rd is simplified. All right. So you got to be able to keep it straight. If it's the product power or the power, or the product property or the power property. All right, example 2, we're going to simplify. Okay, so again, we need our like bases together. Okay, that's always our goal, is our like bases together. And that should help us in doing this. So this is when that commutative property is going to apply. We're going to move some things around. Okay, so Here we have negative 8x squared yz cubed times the quantity xyz squared. All right, so we're multiplying these things, and there's a coefficient of 1 here. So we just have our negative 8, but we're multiplying our x times our x. That's what we're going to combine. So we're going to have x squared times x. So we're taking this one and this one. And then we have our y here and a y here. So times y times y. And then we have our z cubed, a z cubed here, and a z squared. So times z cubed times z squared. All right, so then we've got negative 8. We're going to combine our x's. So we have our same base, so we add our exponents. I'm going to put that 1 up there. So this is going to be 8x 2 plus 1 power. The y, each of these should have a 1, right? So this is the y1 plus 1 power. And then we have a z 3 plus 2 power. When you are doing this at home, you don't have to show me all the addition things once you get the hang of it. Okay, you can just write your final answer, but I'm showing it all to you today. So this is going to be 8x cubed y squared z to the 5th is that simplified problem. Okay, now B is going to be a little bit different. Okay, this is where that associative property comes in, because the cube of the 3 here applies to every single part that's inside here. So the negative, well, that's negative 1 cubed times a cubed times b squared. That quantity is cubed. So this power of 3 outside the parentheses goes to every single part inside the parentheses. All right, so negative 1 cubed, well, that means negative 1 times negative 1 times negative 1. A negative 1 times negative 1 is a positive 1. Positive 1 times negative 1 is negative 1. And then we have a cubed. And then here, when we need to use the power property, which means 2 times 3. So this is going to be b to the 6th, because 2 times 3 is 6. And if you don't want to write the coefficient of 1, you don't. You could just have negative a cubed b to the 6th. That is also correct. So either of those is fine. Okay, I'm going to erase that and move up a little bit more. Okay, so the power of a product is equal to the product of the powers. That's what we just did. Okay, so we had inside our parentheses, we had a, b, c to the nth power. And that meant the n went to every single term inside there. So we had a to the n times b to the n times c to the n. Okay, so that's just saying the power of a product, which is here, the power of a product of numbers, is equal to the product of the powers. So I'm raising this number to the product and I'm multiplying it by another one. Okay, but only like terms can be added when you are simplifying. Okay, only like terms can be added when you are simplifying. So in example 3, we want to simplify. Has to be like terms. So let's look at this first one. Notice we've got this cube out here, this power of 3. We need to distribute it to everything inside. So there's going to be negative 2 cubed times m to the 4th cubed times n. Oh, I don't need the parentheses really. I'm going to save myself a little work if my pen would work. Okay. All right, times n to the 3rd. And then everything inside of these parentheses has to have the 2 distributed to it. So it's going to be 1/6 squared m squared n squared squared, because the n here is squared. So lots of stuff. Okay, so negative 2 cubed. Negative 2 times negative 2 is 4. Times negative 2 is negative 8. m to the fourth to the third, we multiply these exponents. So that's going to be m to the 12th. All right, and then we have n to the third. I should have put that in purple. Oh well. Okay, because this is, perhaps earlier I should have put some brackets around this, right? Like this is us dealing with that first term, and this is the brackets of the second one. Okay, which is why here we've changed these to parentheses, right? I don't have parentheses inside here, so I just use a parentheses here. So now let's go to the next one. So 1/6 squared is 1 squared is 1. 6 squared is 36. So this is 1 over 36 times m squared, n squared to the second. We multiply the exponent, so it's n to the fourth. Okay, now we can only combine like terms. Okay, so in this case, we can pull out the -8 and the 1/36. It's -8 times 1 over 36. Okay, those are like terms. And then we're multiplying the m to the 12th times the m squared. So this is going to be m to the 12th plus 2. And then we have n cubed and n to the fourth. So it's going to be n cubed plus 4. So 3 plus 4. All right, so -8 times 36. Let's see, these both have a 4 in common. 8 divided by 4 is 2. 36 divided by 4 is 9. So this is equal to -2/9. Okay, m to the 14th and n to the 7th. Okay, because once we get to that point, we can only combine like terms. The exponent is given distributed to everything. And then when we're multiplying, we can only combine like terms or like bases. Okay. So this next one looks maybe, I don't know, you might think it's simple or harder, but we're looking for those like terms. Okay, we're looking for the like terms. So in this first one, okay, notice we have x squared times x. Well, that's just x to the 2 plus 1 power. Okay, and then we have a y squared. Plus, here in the next one, we have 3xy x squared. Well, we have the x and an x squared. They have the same base. So this is going to be the x, or 3 to the x1 plus 2 power, and then y. And then minus, here we have an x cubed and a y squared, so we can't, those are already as is. There's nothing to combine. So minus 5x cubed y squared. Okay, so x to the 2 plus 1 is cubed, so this is x cubed y squared plus 3 x to the third, or x cubed y, minus 5 x cubed y squared. Okay, so now this one's a little bit different because suddenly we have addition and subtraction. Okay, well, the only way we can add and subtract is if they have like terms. Remember before we've done like 4a plus 3b equals 2a. We can combine these two terms, 4a and 2a, right, when we're solving. If we did minus 4a, we would get 3b equals -2a, because we can combine them because they have like terms. Their coefficient is different. Okay, the number of, they had 2 a's here and they had -4 a's here, but the term is the same. Okay, so when we have addition and subtraction, we can look for like terms. So the terms here are x cubed y squared, x cubed y, and x cubed y squared. The coefficient here, the number in front would be 1. I have 1 of these. I never write it, but I have it. Here I have 3 of these x cubed y's, and here I have -5 of these x cubed y squareds. So are any of those terms the same? Yeah, right? This one and this one, they both have an x cubed y squared. So these are the ones that can be combined. We're going to combine the whole thing though. Let me redo that. So 1 x cubed y squared minus 5 x cubed y squared, that's just 1 minus 5. So that's negative 4. And then we put the term back on, x cubed y squared. This one we couldn't do anything with. It's not like the others. So we just continue with plus 3x cubed y. So you're just combining those like terms. All right. Your homework is there on page 330, and I will see you tomorrow.